Alright, ladies and gentlemen, welcome back to another math video. Today we're going to be talking about factoring polynomials. So all the polynomial division, all the synthetic division, and all that good jazz has been leading up to this, where we want to be able to take something like this, where we have, say, x squared minus, or plus 2x minus 3, and we want to be able to say, alright, is the term x minus 3, is that a factor of our polynomial? The way we would do that is by dividing. We can check that really quickly by dividing. We don't actually have to factor it or do anything like that. We can just check by doing synthetic division. So if we take and set up our synthetic division, after we do the synthetic division, we want this, we want to look at our remainder. Okay, so 1 comes straight down, 3 times 1 is 3, 2 plus 3 is 5, 3 times 5 is 15, negative 3 plus 15 is 12. And 12 is our remainder. Since we have a remainder of 12, this is not, x minus 3 is not a factor of x squared plus 2x minus 3. The only thing that our remainder can be in order for a polynomial to be a factor of another polynomial is 0. If we have a remainder of 0, then that term is a factor. And so quadratics we've been factoring quite a bit up until now, but what if we had something like this? 2x to the fourth plus 8x cubed plus 2x plus 8, and we wanted to divide that and check and see if x plus 4 is a factor of that thing. So we take a look and we say, all right, let's set up our synthetic division. And once we set up our synthetic division, we want to make sure we have a placeholder for our x squared term, since we don't have one of those. But we are hoping for a 0 right here. We want a 0 right here in order for x minus 4 to be a factor. So we bring our 2 down. Actually, you know what? Go ahead and give this a shot. See what you come up with. So after doing synthetic division, hopefully you found that you would indeed have a remainder of 0. Since you have a remainder of 0, x plus 4 is a factor, of that big thing, okay, of that polynomial. All right. So that's the first thing that we are talking about today. And the second is going to be actually just factoring. So sometimes, this won't always work, but there are times when you'll have a polynomial that will be nice. So if we have a third degree polynomial, so we have x cubed plus 3x squared minus 4x minus 12. Okay, so if you remember, when we would factor, we would split into, we would have something, ax squared plus bx plus c, and we would split b into like dx plus ex, and we'd have ax squared plus dx plus ex plus c. So we would then say, okay, what do these two have in common, and what do these two have in common? We're going to do the exact same thing over here. So this is called factoring by grouping. Okay, factoring by grouping. Okay, so we're going to take a look at these first two terms and say, okay, what do these two have in common? Well, these two both have an x squared, so we can factor that x squared out, leaving us with x plus 3. And then we'll say, what do these two have in common? Well, this has a negative 4, so they both have a negative 4, leaving us with x plus 3. Now, since this parentheses is the exact same as this parentheses, we can continue. If we do this and we get this parentheses is not the exact same thing here, we'll have to take a different path, and we'll talk about what that is later. But if it works, then that's great. So we can factor out x plus 3, leaving us with x squared minus 4. Well, this x squared minus 4 is a difference of perfect squares. So we can say, all right, this factors completely down to x plus 3 times x plus 2 times x minus 2. Okay? So this is a completely factored form of this polynomial, of this original polynomial. Okay? Let me give you another one to practice. All right, go ahead and give this one a shot. This 2x cubed plus x squared plus 8x plus 4. Try factoring this guy the same way we did. Group the first two terms, group the last two terms, factor out the thing they have in common, and then factor out the parentheses. All right, welcome back. If we take a look at these first two terms, we'll see that they both have an x squared in common. We factor that out, leaving us with 2x plus 1. Then these second two terms, we see that they have a 4 in common. We factor that 4 out, leaving us with 2x plus 1. Since this parentheses is the exact same as this parentheses, we can then factor this out from both of these two terms and get 2x plus 1 times the stuff that's left over, so x squared plus 4. Now, it might be tempting to go ahead and continue factoring that just like we did over here, but big difference. This guy has a minus sign, this guy does not. Okay, this guy does not have a minus sign. Therefore, since it's not a difference of perfect squares, this is done. This is all we can do. Okay, we can't keep going. We can't go any further than that. If we did, we would have imaginary numbers. So don't worry too much about continuing on and factoring that. Okay, so just like factoring by grouping is a thing, we can also have a special rule for perfect cubes. Okay, perfect cubes. All right, and this is just going to be sort of a formula, a thing you'll want to remember, a thing you want to have handy, so that way you can refer to it. So these are the rules. So first we have a sum of two cubes. So whoopsie daisies, that was not what I wanted. First of all, we have the sum of two cubes, and then we have the difference of two cubes. So they're going to look like this: something cubed plus something cubed, or something cubed minus something cubed. Okay. If we have this sort of situation where we have two cubes that are added together, we can take and figure out what the cube root of those things are, and then plug them into this equation wherever a and b is. So let's take a look at a couple examples. Let's say we have 5x to the fourth plus 40x. Now remember, back when we started factoring, first thing I told you to look for was always, do they have something in common? Is there something in common between these two things? Well, yeah, 5 divides nicely into both of these, 5, and then they both have an x, so we're going to factor out an x from both of them, leaving us with x cubed plus 8. Okay? Now, x cubed is a perfect cube, and 8 is a perfect cube. So, since we are adding these together, we're going to use this equation. So, we can then say 5x times, we're then just going to say, all right, what is the cube root of x cubed? Well, that's just going to be x. And then what's the cube root of 8? We're just going to say what times itself is going to be 8. That's 2. So wherever we see an a in our formula, we're going to plug in x. Wherever we see a b in our formula, we're going to plug in 2. So we have x plus 2 times x squared minus x times 2 plus 2 squared, which we can then simplify and say, all right, 5x times x plus 2 times x squared minus 2x plus 4. So that's how we would sort of manipulate this function, manipulate this rule in order to work for us. So let's give you an example to try on your own. Let's do 8y cubed minus 27. Okay. So use this difference of two cubes rule and see if you can come up with what that should factor out to be. Spoiler alert: this thing right here, the thing that ends up in parentheses, is almost never going to factor. I don't want to say never because I can't think of an example I can't think of a proof where it doesn't, but it's almost never going to factor. You can just leave it in parentheses like that. All right, so give this one a shot, and let's see what you come up with. All right, hopefully you came up with something like this. If we take and we break this down, we find the cube root of 8y cubed. That's going to be 2y. If we find the cube root of 27, that's going to be 3. Please stop making triangles. If we find the cube root of 27, that's going to be 3. So next, we take and plug those into our formulas wherever they apply. We take and plug those into our formula wherever they apply. And since we are subtracting here, we're going to use this formula. So cube root of 8y cubed is 2y minus 3, which is the cube root of negative 27. And then we take and plug into the second part, 2y, we're going to square that. 2y times 3, and then we're going to square 3. So then cleaning up a little bit, 2y squared is going to be 4y squared, because that square has to hit both the 2 and the y. Then 2 times y times 3 is going to give us 6y, and then 3 squared is going to give us 9. So that's going to be how we're going to work through these perfect cubes and these sum and difference of perfect cubes problems. Okay, just have these formulas. These formulas are super important. They're going to be super useful for you down the road, and use those to help you with these particular problems. All right, if you have any questions, be live every day from 1 to 2. Or if you need anything else outside of that, just let me know, and I'll be happy to meet you then. All right, with that, I bid you adieu. Have a wonderful, wonderful day, and I will talk to you later. Bye, guys.